All right, so this video is going to go over pages 10 through 12. We're just going to draw basic free body diagrams on this one. I'm not going to go through all the separate instructions here. We're just basically going to show what forces are acting on an object. So this little example here, you have your normal force that's acting back up on an object. Now, that only happens if it's in contact with a material. So like you'd have to have like a table or something here. Your applied force, which is, say, it's being pushed to the right. Okay, you would have an applied force. You have your frictional force, which is going to go against your applied force. And you have your force of gravity, which is pulling an object down. Okay, the key thing is before you start doing these is there doesn't have to always be 4 of these going on. Okay, so just don't assume that all these have to happen or you have to use all 7 of the ones we just talked about in the previous problem. You just have to look at each scenario and just figure out what's going on. So number 1 is we have a book at rest on a tabletop. So we're going to draw a tabletop. Doesn't have to be crazy. And we're going to say this is the book. Okay. Now, doesn't say anything about moving at all. It's just sitting on it. So it's sitting at rest on a table. So it's not being pushed. Okay. So that means there is no applied force. So you don't need to worry about drawing an applied force or a frictional force. It's just sitting there. Okay. Now, what is happening is gravity is pulling that book down. So you do have an FG. Okay, and since it's sitting on a surface, that is also going to have an Fn acting right back in the opposite direction. So that table is actually pushing back against that book. So that's called your normal force. So that's it. That's all you had to draw. So there was no applied force, no frictional force. That's all you had to do. Number 2, a picture frame is suspended motionless, so it means it's not moving, from a ceiling by 2 ropes. Okay, so I'm going to draw a nice little picture frame right here. Okay, it's being suspended by 2 ropes, so we'll say those are our 2 ropes. Okay, so now it's hanging. Okay, so remember we talked about when you have an object like a string, a rope, a chain, cable, okay, what's going to happen is you're going to have tension force. So both those ropes are going to have tension force acting on them, and what they're doing is they're holding that picture frame up. Now, what's pulling that picture frame down? Okay, that is your force of gravity. Okay, so there is no applied force, no frictional force. It's just 2 ropes that have tension, and then you have your gravitational force. Number 3, an egg is free falling from a nest in the tree. Neglect air resistance. So you got to make sure when you're reading these, make sure you read it thoroughly. So I have something falling, so I'm just going to draw. You can draw an egg if you want to. Okay, so we'll just say that's our egg. Okay, it is falling, so Fg is pulling it down. Now it's not on a surface, so we don't have to worry about Fn. There is no FA, there is no FF, okay? It says neglect air resistance, so we don't have to worry about that air resistance pointing in the opposite direction. So that was it, that's all you had to do. Now, a flying squirrel is gliding, no wing flaps, from a tree to the ground at a constant velocity. That means this squirrel is just going down. That's it, it's not actually going left to right or anything like that, it's just going down. So consider air resistance now. Okay, so we're gonna draw this squirrel, we're just gonna draw a box here. Okay, diagram the forces acting on it. So there's no applied force, no frictional force. Okay, so we're not trying to push it left or right. Okay, what's pulling it down is Fg, but it's going at a constant velocity, which means your Fn is balanced out. I'm sorry, not Fn. My apologies on that one. That is your F air. Okay, that is your air resistance. If you reach a constant velocity, that means your force of gravity and your air resistance has become equal. Okay, so like when you pull your parachute, okay, it wouldn't do you too good if you just kept picking up speed even with that parachute out. Okay, so what that parachute does is it increases your air resistance, which is going to bring you to a lot slower or constant velocity. Okay, so that's all you got to do for that one, number 4. Number 5, a rightward force, so we're going to the right, is applied to a book in order to move it across a desk with a rightward acceleration. So keyword there is acceleration. Consider friction, so friction is there. Neglect air resistance, so we'll talk about that. And we're just going to diagram what's happening. Okay, so we're going to draw our desk, and here's our book. Okay, so a rightward force is happening, so we're pushing it to the right, so we're FA. Now, it says it's accelerating, so that means it's overcoming friction. Doesn't mean it's not there. It just says that frictional force is smaller. So FF is going to be the opposite way, and it's just going to be smaller than your FA. Now, FG is still pulling it down, okay? And then that table is still pushing back up with FN. Now, when it says neglect air resistance, that doesn't mean we're dropping it. That just means when you naturally push something, there is going to be some form of air resistance. So that means that basically says that there would be, in real life, there would be another amount of resistant force that would be air resistance. But we're not going to worry about that one. So we're just going to worry about frictional in this case. So that would be your drawing right there. Just FA is bigger than FF. Now this one, basically the same problem. Okay, a rightward force is applied to a book in order to move it across the desk at a constant velocity. So key there is constant velocity. Consider friction, so it's there. We're not going to worry about air resistance, so we're going to draw basically the same thing. So here's our book. So FG is pulling it down. FN is pushing it back up. And you have your applied force, so FA. Now, since it's a constant velocity, that means FA and FF are going to be equal. So everything is nice and balanced out, so you're good. Number 7, a college student rests a backpack on his shoulder. Okay, the pack is suspended motionless by one strap, so it's not moving, by one strap from his shoulder. Okay, so basically what we're going to do is we're going to say this is his backpack, this is his strap, okay, that's hanging from his shoulder. So that's going to be a tension force right there. And since it's not moving, okay, that means it's staying still. That means that tension force and the force of gravity have equaled out. Okay, so those would be the same. And that's it. Number 8, a skydiver is descending with a constant velocity. So constant velocity. Consider air resistance. Okay, diagram the forces acting upon the skydiver. So we're just going to draw our skydiver here. So FG is pulling it down. Okay, so there is no surface. There's no FN. Okay, there's no FA. There's no FF. Okay, but it says consider air resistance, and it's a constant velocity. So remember, constant means balanced out. So that means that F air is going to be the same as your FG. Okay, so that's it. Number 9, a force is applied to the right to drag a sled. So we're going to the right. To drag a sled across a loosely packed snow with a rightward acceleration. So keyword there is acceleration. Okay, so what we're going to do is we're going to draw our snow. Here's our sled. We're pulling it to the right. So FA, we're accelerating, so that means friction has to be smaller. So FF is going to be smaller. FG is still pulling it down against that snow, and that snow is pushing back up with an FN. And that's it. Number 10, a car is coasting. So this is probably the most confusing one. Coasting means you're not doing anything. You let off the gas. There is no longer an applied force to the right. Okay, so it's slowing down, which means friction is slowing it down. So here's your car. So it's on the road. So we're going to draw our car here. That means there is no applied force. There is no arrow to the right. Yes, is it moving to the right? Yeah, but we're not actually applying a force to the right. We're actually just coasting. Okay, that means that the only thing acting on it in the horizontal plane is friction force. And if you're coasting, you will slow down and eventually stop. So that means friction force will keep working against you until you do stop. Now, if you're on the ground, you're exerting FG, okay, on the ground, and that ground is also pushing back up with FN, and that'll end that one.